This will be for the con exercise, trig values of special angles. So before doing this exercise, you need to be familiar with special right triangles. And in the case of a 45, 45, 90 degree triangle, you need this formula. The hypotenuse is going to equal leg times radical 2. And in the case of the 30, 60, 90 degree triangle, the hypotenuse is going to equal 2 times the shorter leg. And the longer leg is going to equal the shorter leg times radical 3. Okay, so you need those formulas for this exercise. All right, so we want to find the following trig values, express answers exactly, cosine and sine of 150 degrees. Okay, so for all of these exercises, they're going to be asking for both the cosine and the sine, and the angle measurement is going to be the same for both the sine and cosine on each problem. All right, so in this case, our angle theta equals 150 degrees. Let's draw that on the unit circle. All right, so we have our unit circle on the XY coordinate plane. We said that the angle theta equals 150 degrees. Let me double check that. Yes, it's 150 degrees. Okay, recall that you start your angle on the positive x-axis. All right, so we're going counterclockwise 150 degrees. Now, if we go here, that's 90. And if we go all the way to here, that's going to be 180 degrees. But we're only going to 150. So let's stop before we get to 180 degrees. All right, so you want to draw in the radius. Start at the origin, which is the center of the circle, and go to the circle itself. All right. Now, if we had gone all the way here, it would have been 180, but we only went 150 degrees. So this angle right in here would have to be 180 minus 150. This angle right in here is 30 degrees. All right. And you want to go to the end of the radius where it meets the circle and construct a right triangle. All right, so you just go down to the axis from the end of the radius. You just draw the line straight down to the axis and you make a right angle. All right, and you want to get that angle inside the triangle. If this is 90 and this is 30, this one here has to be 60. All right, because we know the angles inside the triangle add to 180. Now, on the unit circle, we know the radius is always 1. All right, and that 1, that radius, is always going to be the hypotenuse across from the right angle. So let's see. I am going to do the short side first. Okay, the short side is the one that's across from the 30-degree angle. And from our formulas, we said that we have the hypotenuse, because that's across from the right angle. We said the hypotenuse equals the short side times 2. All right. The short side is the side across from 30. So I am just going to call this side length y. Okay, you can call it whatever you want, but since it is the vertical side length, I would like to call it y for the y-axis or the y-coordinate. All right, so across from your right angle, that's your hypotenuse, that's 1. The short side is across from 30, we called that y, and that's going to be times 2. All right, and solving for y, you just simply divide both sides by 2, and we can see that y equals 1/2. All right, so that's the short side. And now for the long side, that will be the side that's across from the 60-degree angle. So this side right here is going to be the long side. I'm just going to call that X. Again, you can call it what you want. However, to me, it makes sense to call it X since it is the left, right, or horizontal distance matching the X-axis. So the other formula, other than the one for the hypotenuse, is going to be the long leg equals the short leg times radical 3. Okay, and we said the long leg across from 60, we called that X. We found the short leg a minute ago, that's 1/2, and that's times radical 3. All right, and let's see. This is just going to be radical 3 over 2. All right, so we're almost done here. And the idea is to get the coordinates for this point right here. Now, we said in another exercise that the x coordinate is going to be the cosine of theta, and the y coordinate is going to be the sine of theta. All right, so that's why I called this x. This x coordinate is the cosine of theta. And we said theta, this angle right here, is 150. So the cosine of 150, we just need to watch our plus minus sign. Okay, the length of this side may be radical 3 over 2, but the coordinate for this point, we can see this point is in the negative x area. Okay, this quadrant right here, the x's are negative. So this radical 3 over 2 is actually going to be negative. All right, so that's going to be negative radical 3 over 2. And the other one is going to be for the sine. All right, the sine of 150. Well, that is your y coordinate. Okay, now the length of this triangle is positive, but is the y coordinate positive? Well, yes, in this case it is. If you trace this, if you eyeball this to the y-axis, we can see we are in the positive y-axis area. So this y-coordinate is positive, and the y does not change. The plus-minus sign does not change. So the sine is positive 1/2, but the cosine is negative radical 3 over 2. All right, so after you find the side lengths of your triangle, we know side lengths are always positive, but coordinates are not always positive. So you'll have to determine the plus-minus sign of the coordinate at the end. All right, so it's going to be negative radical 3, click outside, over 2. And for the y-coordinate, it was just positive 1/2, 1/2. All right, let's do one more. We have cosine of and sine of 225 degrees. By the way, on all these problems, I believe the angles will match, and they're just going to ask you the sine and cosine. Okay, so once again, we start at the positive x-axis, and we're looking to go 225 degrees. All right, this right here would be 180. So we're going to go around this way. That's 90, 180, and a little bit further is 225. Okay, so just draw in the radius. And let's see. If this is 180 and we went all the way to 225, this angle right here is just going to be 225 minus 180. So this is a 45-degree angle right here. All right, once again, construct a right triangle by just drawing a line from the point to the axis. Okay, find the end of the radius on the circle and just draw the segment to the axis. Make a right angle. Okay, across from your right angle, that radius is 1, so your hypotenuse is always going to be 1. If this is 45 and this is 90, this angle here is 45. All right, and this formula is much simpler. We said before, for 45, 45, 90, the hypotenuse is just the leg times radical 2. All right, so let's find one of the legs first. This one right here, just as before, we'll call that x. Okay, that's one of the legs. And we know the hypotenuse is 1. And the leg, we just called it x. And that's times radical 2. Solving for x, divide both sides by radical 2. Cancels here. I am not sure if they will accept this answer, so let's do it in the form so there's no square root in the denominator. Okay, you take your 1 over radical 2 and just multiply the top and bottom by radical 2. This is the same as multiplying by 1 in the numerator, 1 times radical 2. In the denominator, radical 2 times radical 2 is just 2. So that equals x. And on the other leg, across from the other 45, this right here, we can just call that y. Okay, now, across from 45 and across from 45, you're going to get the same thing. So the y coordinate, you don't have to do the formula again. The y value is also going to be radical 2 over 2. Now, once again, just like last time, we need to do our final step. Okay, we have the cosine of 225. And we have the sine of 225. Now, we said the cosine is our x-coordinate. Okay, for x, we got radical 2 over 2. But in this section here, the x's are negative. See this point right here? The x value is going to be negative. So it's going to be negative radical 2 over 2. And for the y-coordinate, the y value is also going to be negative. See, if we trace this to the y-axis right here, the y value is also negative. So we said y-coordinate is the sine. That's also going to be negative radical 2 over 2. So these are both the same answer for both of these. Out of curiosity, I'm going to try to enter the answer in the non-simplified form, see if they take it. If not, then I'll go with these right here. Of course, it still has to be negative, okay, but I'm going to try and enter it like 1 over radical 2. Okay, so negative 1 over square root of 2. And then in the other one, same thing. Negative 1 over square root of 2. Let's see if they accept that. Okay, so apparently they let you do the square root in the denominator. Okay, but it's a good practice to simplify it and get the square root out of the denominator. All right, let's do one more. Okay, now for this, since there's a pi in the angular measurement, obviously these are in radians. All right, I would translate that to degrees. So we know that pi radians equals 180 degrees. All right, so the simplest way is to just plug in 180 where you see the pi. So 3 pi over 4 that is equivalent to 3 times 180 divided by 4. And that just equals 135 degrees. So that is the same thing. We're looking for the cosine and sine of 135. All right, so once again, we're starting at the positive x-axis and heading around counterclockwise. All right, this is 90. This is 180. And if we head in this direction, that's 90. We don't want to go all the way to 180. We want to go a little past 90. Right there. Draw in your radius. Okay. Now, if the angle is 135 and this is 90, this part was 90, so this right here is 135 minus 90, so that's going to be 45. Okay, once again, construct your right triangle, and yeah, you just want to draw the line from the end of the radius to the axis and make a right angle. Okay, your hypotenuse is always going to be the radius, so that's 1, and this right here is going to be a leg, and this is 90, 45, this is 45, and this is going to be a leg right here. Okay, so I'll leave it there for you to finish, but the process is basically the same as before. The only thing you have to remember in this case, that this point right here, the end of the radius here, the x's are going to be negative, so the cosine is going to be negative, but the y value is going to be positive, so the sine is going to be positive. Other than that, you're just using the special right triangle method once again.